Let's take a look at more examples, everyone. So here we have hyperbolic paraboloid, which is defined as x squared minus 3y squared. Sketch the contour map for this object. As you remember, you're going to set the z values equals to fixed values, k, c, z sub 0, whichever you feel comfortable, it doesn't matter. Different books use different notation. X squared minus 3y squared is equal to c. Well, what's the meaning of that? If c is non-zero, the level curve is hyperbola. X squared minus 3y squared is equal to c. Well, we can simplify this as well. Get 3y squared equals to x squared minus c. So y squared is x squared divided by 3 minus c divided by 3, or y becomes plus minus square root of x squared minus c divided by 3. If c is equal to 0, then the level curves consist of two lines, right? Here you get x squared minus 3y squared equal to 0. So 3y squared is equal to x squared. If you take square root of both sides, you get square root of 3 times y equals to plus minus x. You can also factor it this way. X minus square root of 3 times y times x plus square root of 3 times y. When you set it equal to 0, you get two sets of lines. So this is your 3D object. This guy is in the space. You look at the level curves in 2D. So that's the difference as we described it before. If you look at the projection of this 3D object in 2D, XY plane, these are the level curves. These are the projection of this object in 2D. So for a 2D observer, these are the behavior of this 3D object in the space. But again, remember that these 3D objects are level surfaces of 4D objects. So here, if you have a 4-dimensional object, the projection in the 3D is like this. And the projection in 2D has a bunch of curves. As you see, you have lines and you have parabolas. You have hyperbola as well. So that depends on what we are dealing with. Again, 4-dimension to 3-dimension, and from 3-dimension to 2-dimension. These are the behavior of this object. But what is the 4D object? Well, for now, we don't have any visualization of that. We can just analyze this in 3D and also in 2D. Maybe there are super fast computers that can help us visualize this in 4-dimension. So in this question, I ask you to find the level surfaces of this 4D object. Guys, note that you have 1, 2, and 3 free variables. And this guy is the output. You can denote this by W if you want to. Well, we set this equation equals to K. Now, remember the definition of a sphere. Sphere centered at the origin is x squared plus y squared plus z squared equals to r squared. So in this case, your r squared is equal to k. And since r is the radius, we don't accept the negative sign. So that's why you see the radius to be square root of k. Now, The visualization should be very easy for you. Why is that? If I set k equal to 0, this is basically the center. K equal to 0, you have x squared plus y squared plus z squared equal to 0. The only point satisfy this relation is 0, 0, and 0, which is basically the center, or in this case, the origin. When k is equal to 1, well, you have a unit sphere, which is this sphere here. Remember, we call this guy unit sphere. We can continue this process. If k is equal to 3, you get square root of 3 as the radius. If k is equal to 2, you get square root of 2 as the radius, and so on. So for simplicity, we use 4 and 9. So again, these are for simplicity. You could take other values. You can say, hey, k is equal to 2. So x squared plus y squared plus z squared is equal to 2. So the radius is now square root of 2. When k is equal to 3, you get x squared plus y squared plus z squared equals to 3. So the radius is square root of 3. You get smaller spheres. But as you can see, they have the same center. So you get concentric spheres as level surfaces for this four-dimensional object.